Hello, students, future engineers, and subscribers. Here is a sample problem video on non-sway frame solved by the moment distribution method, and it is also solved before by slope deflection equation. So this time, let's solve this by the moment distribution method. I just compute for the moments at the joints, and remember the answers should be close or nearly equal because this is moment distribution method. So first, let's solve for the stiffness of its member. AB, the joint A is pinned. Therefore, we have to modify its stiffness by multiplying 3/4. 3/4 of 1 over 8 is 3 over 32. This is an interior segment. We expect moments at B and C. So the stiffness is 1 over 4, 1 over L. This is again 3 over 32, 3/4 of 1 over 8. And this one is 1 over 6 because the far end E is fixed. So the stiffness is 1 over 6. Then we compute, let's have the frame. For this one, the the distribution factor is negative 1.0. Here, 3 over 32 divided by 3 over 32 plus 1 over 4 and make it negative, negative 3 over 11. So therefore, 11 minus 3, this is negative 8 over 11. For this member, for this, the distribution factor of this member CB is 1/4 divided by 1/4 plus 1/6 plus 3 over 32, and that is negative 24 over 49. Then replace 1/4 by 1/6. This is negative 16 over 49. And 49 minus 24 minus 16 is 9. So the distribution factor of CD is negative 9 over 49. And for D, it is negative 1.0. And at E, it is 0 because E is fixed. So negative 1.0. Compute for the fixed moment at B. Negative 30 times 2 square over 4 square. Negative 15 by symmetry. This is positive 15. Here, negative WL square over 12, negative 20, 6 square over 12, so negative 60. And by symmetry, this is positive 60. We then distribute the moments. Negative 15 times negative 8 over 11, it is 10.909. We lock it partially. Then negative 15 times negative 3 over 11, put the value here, 4.091, lock partially. 15, quantity 15 minus 60, negative 45 times negative 24 over 49. Put the value here, partial lock 22.041. Then replace 24 by 16. Put the value here. You have 14.694 lock partially. Then replace 16 by 9. Then the value, put the value here, 8.265 lock partially. Then of course 60 times 0 is 0, lock partially. So the carry over, half of 0 is 0. Then half of 14.694 here. Half of 22.041, 11.02, half of 10.909 here. Don't mind this because there are no loads here, no moments to be distributed. So take note that this is the distributed moment from this joint, not the unbalanced moment, and should be distributed here. So this will no longer receive moments. Anyway, the final moments at A and D are expectedly 0. So 11.02, this is the blue ones are the unbalanced moments, the new unbalanced moments. So we distribute this 11.02 times negative 8 over 11 is negative 8.015, lock partially. 11.02 times negative 3 over 11, negative 3.005, lock partially. 5.454 times negative 24 over 49, negative 2.671 lakh partially. Replace 24 by 16, 5.454 times negative 16 over 49, negative 1.781 lakh partially. 5.454 times negative 9 over 49, negative 1.002 lakh partially. 7.347 times 0 lakh partially. Half of 0 half of negative 1.781 here, 0.89, negative 0.890. Half of negative 2.671, negative 1.36, half of negative 8.015 here, negative 4.008. Distribute negative 1.336 times negative 8 over 11.972 lakh partially. Negative 1.336 times negative 3 over 11.364 lakh partially. Negative 4.008 times negative 24 over 49 1.963 lakh partially. Negative 4.008 times negative 16 over 49, put the value here, 1.309 lakh partially. Negative 4.008 times negative 9 over 49, 0.736 lakh partially. Negative 0.89 times 0 lakh partially. Half of 0 is 0. Half of 1.309 here, 0.654. Half of 1.972.486. Half of 1.963, 0.982. 0.982 times negative 8 over 11, negative 0.714 lakh partially. 0.982 times negative 3 over 11, negative 0.268 lakh partially. Then 0.486 times negative 24 over 49, it is negative 0.238 lakh partially. 0.486 times negative 16 over 49, negative 0.159 lakh partially. 0.486 times negative 9 over 49, negative 0.089 lakh partially. 0.654 times 0 lakh partially. Half of 0, half of negative 0.159, negative 0.08, half of negative 0.714, negative 0.357, half of negative 0.238 here, negative 0.119. Negative 0.119 times negative 8 over 11, 0.087 lakh partially. Negative 0.119 times negative 3 over 11, 0.032 lakh partially. Negative 0.357 times negative 24 over 49, 0.175 lakh partially. Negative 0.357 times negative 16 over 49, 0.117 lakh partially. Negative 0.357 times negative 9 over 49, 0.066 lakh partially. Negative 0.08 times 0 lakh partially. Half of 0, half of 0.117, 0.058, half of 0.087, 0.044, half of 0.175, carry over there, 0.088. Then 0.088 times, there are still values like here where the unbalanced moment is greater than zero point 0.1. So this is carry over. These are the new unbalanced moments. We should end up at distribute. So we have to distribute this finally. 0.088 times negative 8 over 11 is negative 0.064 lakh final lakh. 0.088 times negative 3 over 11, negative 0.024 lakh, then lakh it finally. 0.044 times negative 24 over 49, 0.022, negative 0.022 lakh, then lakh finally. Then 0.044 times negative 16 over 49 is negative 0.014 lakh finally. 0.044 times negative 9 over 49 is negative 0.008 lakh finally. Then 0.058 times 0 lakh finally. So adding this column values here. The moment BA is 1.190. Adding these column values, the moment BC is 1.19 negative 1.190. Adding these columns here, the value is equal to 15 plus 22.041 plus 5.454 minus 2.671 minus 4.008 plus 1.963 plus 0.486 minus 0.238 minus 0.357 plus 0.175 plus 0.044 minus 0.022, and the value is 37.867. Then here, adding these values here, that's the value. Then here it's 7.968, and here adding the values here, you have 67.089 kilonewton meter. So that's it. And compared the answers, they are very close to the solutions by three moment equations.